All right, everyone, this is part 2 of our one variable stats cycle 1. This part, actually part 1 and part 2, we're talking about having a data set and then ways we can display it. And so for part 1, we learned how to create a frequency table, a histogram, and a dot plot to display data. And on this video, this tutorial, we're going to learn how we can display data, the same data as we displayed on part 1, but by using a box plot. And some of you might actually already know how to do this and might have heard, but another name to call it is a box and whisker plot. Because essentially a box and whisker plot looks something similar to this. So we have our box and then we have our whiskers. And so box and whisker or box plot, whichever one, we're going to learn how to actually create one of those given a data set. So let's fill in the blanks. A box plot is a standardized way of displaying the distribution of data. So in other words, where is the data mostly? Is it where is the data? Is it in the lower end of the range? Is it in the middle? Is it in the higher end? So it helps us kind of see throughout the range of our data set. So in this specific set, we have the numbers 1 to 20. So throughout that range, where is the first 25%? Where's the second 25%? Where's the third 25%? Where's the fourth 25%? So we can pull some analytical things off of that once we actually have it created. So the distribution of the data set based on the 5-number summary. So we have the minimum, the maximum, the median, and then we have things called Q1 and Q2, which I'm going to explain to you here in a second. But just so you know, Q1 is quartile 1, and Q2 is quartile 2. Hopefully you see quart or like quarter, and so you know that this is going to basically take our data and put it into 4 sections. And I have kind of a candy bar analogy that hopefully gives you a visual of how to create this box and whisker plot, this box plot. Okay, so here's our example. The number of text messages that, as an example, the number of text messages that students sent yesterday between 8 a.m. and 9 a.m. are displayed in the data set below. Create a box plot to organize the data. So here is our original data, and just for time purposes, I went ahead and put our data in order, which is something you will want to do when you create a box plot. So you want to make sure data is in order. Okay, so it's super important. Make sure you put your data in order. So I'm going to take a 30-second break really fast and ask you to visualize something. So let's say that you and 3 of your friends, there's 4 of you total, want to eat this Hershey bar. I want you to think about how you would split this Hershey bar as evenly as possible. And so one thing that you might do is split it down the middle, and then take this half and split it, and then take this half and split it. Another scenario that I asked last year was, if you have a cookie, how would you split this among 4 people? And so with a Hershey bar, it's pretty obvious where you would break it. But if you think about a cookie and you have to split it with 4 people, you would first split it in half. That is not a good half. You'd first split it in half, and then you would take the left half and split it, and then you would take the right half and split it. So you're cutting something in half, that's the median. You're taking this left side, cutting that in half, taking the right side, cutting that in half. And if you can visualize that, you can actually, that's a great way to visualize what a box plot is. So if you have problems kind of understanding that analogy, pause the video, raise your hand, and I'll come around and talk to you about it. But if you're like, yeah, I get it, that makes sense. If I had a cookie or a candy bar, I'd break it in half. I'd take both halves and break those in half. You have just created a box plot with a cookie, essentially, or with a candy bar. So let me tell you what I mean by that. Oops. Okay, let's get rid of some of this right here. So The first step of creating a box in Whisker plot is that you want to break the data in half. And so the median is your half, okay? So the median is the middle number. So if we look at this data set, we have 26 data points. So I know that I can count 13 from both sides and I will find the middle. So I'm going to count over 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then if I count from this side, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So now I know my middle is right between this number. So my median is at 6. So if you think about breaking this data in set, I have a 6 here and a 6 here. And so I've kind of broken it right in between them. Now I want to take this left half and I want to break that in half. So I want to find the median again. So I have 13 numbers in this half of the data set. So if I find the middle of 13, I'm going to count 6 from each side, and then that middle number will be my 13th number. So I can count 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And it leaves me with this middle number. So 3 is actually the middle of my left side of my candy bar, the left side of the data. So I'm going to do that again on the right side. So I have this data set right here and I want to find the middle. Well, there's 13 numbers there, so I have to count 6 from either side, and then the number left over will be my center number. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, leaving this right here, 13, as the median of my right half. So I have the actual median of my data set is the number right here between 6 and 6. So the only number there is no number between 6 and 6, because 6 and 6 are the same number. So the median of my data is 6. This 3 represent our first quartile, and this number 13 represents our second quartile. So our first quartile is 3, our second quartile is 13. The end of our candy bar is the end of our data. This end of our candy bar is the end of this data. So our minimum is 1 and our maximum is 20. Now, there is something that you want to keep in mind. If I had a very obvious outlier, either way down on the low side or way up on the high side, that number is not going to be part of my box plot, and I'll show you that here when we actually draw it. For this data set, we don't have any outliers, but if I added the number, let's say 50 to my data set, that would not be my max because that's an outlier, and so we would just keep the number 50 way out here, and I'll show you in a second how that would be displayed, but take out the outliers and then you would do this data set. Okay, so let's draw this box and whisker plot. So I'm first going to number my number line. So I'm going to go 1 to 20. Okay. So the minimum number will have a dot above it, and the maximum number will have a dot above it. So the dots represent the min and the max. The next part of it is we have a box. So the one side of our box goes on our quartile 1. So at 3. And the other side of our box goes at quartile 2. So at 13. We're going to connect this box, and then we have to draw our median. So our median is at 6. So you might be thinking, well, that's not in the middle of my box. It's okay. The box is going to be very skewed depending on your data. We might have a long part of the box, or the median might look like it's really close to the left or really close to the right, and that's okay. It's not going to look even, but it just needs to be represented. So we have our minimum, our first quartile, median, second quartile, maximum. And so now we want to connect the box to the dots. So notice that my box and whiskers are not on the number line, they are above the number line. And that way it kind of keeps it really organized and really clean. So let me go over this just really quickly again. We have this data set we've put in order. We want to break it in half. That middle number is our median. So that middle number is this situation right here. It's our median. When we take the left side of the data set, the lower side, we also want to break that in half. And so that becomes right here our quartile 1. Now we go up to the upper half of the data and we break that in half, and that becomes our quartile 2. Our dots, our whiskers, the end of our whiskers become our minimum number and our maximum number. If we had an outlier, we would just put like a dot on any of the outliers to show that those are in the data set, but they're not connected to the bulk of the data, but we still want to make sure they're displayed. In this situation, we don't have outliers, so we'll learn more about that later. So this is our box and whisker plot. And so one thing I want to make sure you understand is that every part of it is 25% of the data. So this little section is 25%. This is 25%. This is 25%. And this is 25%. Because we've broken it in half. We broke each of the halves in half. So, and it's all even. So 25% of our data is in each section of our box and whisker plot. Even though they don't look even, they are even if you look at the data. And so we will analyze this and compare multiple box and whisker plots in a later lesson. But this lesson, you don't have to fully understand what a box and whisker plot shows, and you don't have to understand the distribution of the data. I just want you to know how to create the box and whisker plot. So hopefully that wasn't too much. If you feel like it was kind of confusing, you can stop the video and ask me in class, or you can try to watch parts of it again just to see if maybe that can clear up some of the misunderstanding. But basically all it is breaking a cookie into 4 parts. Break the middle, take each of the halves, break those in halves, represent it as a box with 2 little whiskers on a number line. And so that's a box and whisker plot. All right, well, I'll see you in class. If you have questions, let me know.